Hi, Assalamualaikum. My name is Afiq. My student ID is 2022-615118. So today I will present about industrial training at Agency Nuclear Malaysia. After that, we go to background of company. So Agency Nuclear Malaysia is a leading government research and development R&D institution in the field of nuclear science and technology. So Agency Nuclear Malaysia is established on 19 September 1972. So the objective of the company is to generate new products and technologies through research and innovation based on the National Development Agenda. We go to background of department. During my internship period, I was placed under the Radiation Processing Technology Division, BTS. So what is BTS? So BTS is Radiation Processing Technology Division, a department dedicated to advancing the use of radiation technology in polymers modification for various applications. Radiation Technology Laboratory (MTS) is under provide service that focus on polymer processing, testing, and analysis activities. Next, we go to position of trainee. During my 14 weeks industrial training at Agency Nuclear Malaysia, I was assigned under supervision of Puan Nurliza binti Ishak in Radiation Processing Technology Division. During this period, I was given the research project, which is the title is Radiation Assisted Modification of Pyrolysis Oil Derived from Plastic Waste. Other activities that I do in Agency Nuclear Malaysia is Pyro Lab Session, 5S implementation in laboratory, equipment and instrument handling, and last but not least is visit the reactor Trega Puspati RTP. So we go to experimental work. So under my assigned project, I have 4 steps, which is preparation sample, irradiation, pyrolysis, and analysis testing. So we go to first step, preparation sample. So a sample of exactly 250 gram was weighed for each dose from 0 kg until 100 kg. So after that, irradiation. So the prepared sample we sent to Sinagama facility for radiation treatment using high energy gamma rays from a Cobalt 60 source. So after that, the main core of this project is pyrolysis. So what is pyrolysis? Pyrolysis oil was produced via pyrolysis gasification using a propylene plastic waste sample. After that, we have analysis and testing our product using GCMS, FTIR, bomb calorimeter, viscometer composition of pyrolysis oil. So let me explain about my research project. Radiation assisted modification of pyrolysis oil derived from plastic waste. So this is my routine or my lab sessions. For each run, a 20 gram sample was used. The pyrolysis process was initiated by heating the reactor in a furnace to 60° Celsius and maintained for 1 hour. To create an oxygen-free environment and prevent combustion, the nitrogen gas was pushed to pyrolysis system. Within a few minutes of heating, vapor was observed indicate the samples was breaking down, and another minute later, the first drop of pyrolysis oil was produced, and marking the pyrolysis reaction occurs. Upon completion, the liquid oil and solid residue were weighed to determine the respective yields of product produced during the pyrolysis process. So this is my research objective, to investigate the effect of gamma irradiation dose on the composition of pyrolysis oil, and second, to determine the influence of doses on the physical properties of pyrolysis oil. So we go to the testing and analysis result. For the first one is composition of pyrolysis oil. So the figures show comparison between non-irradiated sample and irradiated sample using sinar gamma. So for the irradiated sample, for the result was 72.63% of liquid, 27.22% of gas, and 0.15% of solid respectively. For irradiated sample, the solid residue increased marginally to 0.50%, the gas yield decreased to 13.82%, and the liquid yield improved dramatically to 85.68%. So this is happened because this alteration suggests that pretreatment with radiation weakens or breaks polymer chains, increasing their vulnerability to pyrolysis, induced conversion into stable liquid hydrocarbons. So as conclusion, the irradiated sample increase the yield of liquid from plastic waste and have more good quality of liquid. So we go to the next testing and analysis result, which is gas chromatography, mass spectrometry, GCMS. So for this testing, this is the main or common testing for researcher or industry to test their oil. So this result compare between raw sample and irradiated sample in divide to 3 fraction, between light, middle, and heavy. For the raw and irradiated sample shows a slightly same percentage, where the raw sample at 0.10.47 of the heavy fraction decreased to 9.62% for the irradiated sample. Moreover, the middle fraction was proven to be increased for irradiated sample 42.85% to 44.83%, and for the light fraction in raw sample exhibit 46.05%, which is slightly higher than 44.68% observed the irradiated sample. So this result demonstrates that the gamma irradiation prior to pyrolysis influenced the hydrocarbon distribution in the pyrolysis oil result. Therefore, it promotes the formation of middle-range hydrocarbon compound while reducing the proportion of heavy fraction, hence shows an overall enhancement in the quality of the pyro oil and supports the potential of radiation-assisted modification as an effective technique for improving the fuel characteristic of plastic waste-derived pyro oil. And for the last testing that I test for my pyro oil is viscometer test. So for this testing, we calculate or measure a liquid's resistance to flow. As we can see for the result, non-irradiated sample record a viscosity value of is 6.40 cp, while the sample for irradiated is 19.20 cp. So the irradiation may enhance the formation of saturation of polar compounds, which also increase the resistance to viscosity, suggests that the PP material's internal structure has been changed by gamma radiation. As the result, the materials become more linked and knotted, which limits the change range of motion and increase flow resistance. For the next testing is bomb calorimeter. So for this testing, we just calculate the heat of a reaction at a fixed volume. So for this testing, we just highlight the result, GCVs, joules per gram. As we can see at the result, for non-irradiated sample was found to 43310 joules per gram. By contrast, the irradiated sample shows a significantly higher CV of 43370 joules per gram. Also, we found that the higher of delta K value also reflect a greater heat release per unit temperature rise. So for this testing, for non-irradiated sample is 1.9927 and for irradiated sample is 2.1515. Therefore, the radiation-assisted processing might improve the fuel characteristic of pyrolysis oil. So as my conclusion, have to decide two conclusions, which is industrial training, overall of industrial training, and my research project. So for the industrial training, the internship was both exciting and rewarding. Its significance enhanced my academic knowledge and provide me with practical, hands-on experience and sustainable technologies while addressing real-world challenges like plastic waste reduction and energy sustainability. And for the research project, this data collectively indicate the excellent performance of gamma irradiation in improving physical, chemical, and energy characteristics of pyrolysis oil. Therefore, irradiated pyrolysis oil not only yields more but also exhibit superior quality and fuels characteristics, making it highly promising candidate for future application in renewable energy and sustainable plastic waste management. And for the important thing, I have achieved the objective for the research project. So that's all from me. Thank you.